Thanks for coming. I will start this presentation by a story. Once upon a time, a developer was making some plans for his weekend, a Friday afternoon. When at 5 p.m. he got a mail from an ops saying, okay, we have just 500 HTTP error code with just this exception. Cheers. After a while, he was able to reproduce the issue on his desktops, find the root cause, and give a patch to apply into production. The main point is it was not just having an issue into production. This thing can happen, but the main point was the ops wasn't able to pinpoint what was the root cause of the issue due to a lack of contextual information. Why? If this kind of story rings a bell for you, maybe on your project you missed one of the most important features, the observability. After this long introduction, let me introduce myself. I'm Alexandre Touré. I'm a software architect at NTS France within the Transport and Mobility department. And normally this presentation would be also presented by my colleague David Pekegno, who is a performance engineer at GOS. And we are also part of the tech squad, where I have the chance to lead the server performance data and beyond squad. So what about this presentation and the agenda? We will expose what is the observability, what is under the hood, what are the notions behind the term of observability. We will explain it through a use case based on the sample of payment application. And when we show you through coding how to put that in place. So now what is the observability? The observability is based on 3 pillars. The first pillar is the log. It's really important as a developer to provide insightful logs based on several log levels, such as log, debug, info warning, you know that. But it's really important when you have an issue, when you, for instance, when your contract number is wrong, to explain it in your logs, why it's wrong. It's really, by the way, I think that is a staple. Then, if you have, for instance, a distributed application based on microservices pattern, when you have several transactions, asynchronous, synchronous transaction, it will be really cumbersome to know where do you have a lack, where do you have, for instance, a performance issue. The distributed tracing could help you with the traces. Last but not least, how do you know how is the database connection pool, for instance? You will get this insight using the metrics. I will show you during this presentation how to put all of that in place. Nowadays, there are plenty of distribution stack. If you use a GCP, if you use AWS, you can use all the managed service for that. If you use on-premise technologies, you can use, for instance, the Grafana Stack to put in place, to put into production the log traces and the metrics. If you use the Java platform, you will bring logs and you store them using logback, for instance. For the traces, you will use OpenTelemetry, which is nowadays a standard by default. You can use OpenTelemetry for several languages, such as .NET, such as C, such as C#, such as Java, Node.js, and so on. For this demonstration, we will use also Prometheus for storing the metrics. If you use the Grafana Stack, you can use Loki for storing the logs, Tempo for storing the traces, and Mimir for the rest, for the metrics. Based on that, you will be able to create dashboards and alerts. So what about the use case? Yes, as Gilles Guaprinet said before, we're still a payment company and a paytech. So here is a blueprint of what is a payment application. We have the good old, that Jean-François knows well, the EasyPay platform with a main microservices which accept all the payment, one authorization, which is the Smartband gateway. It checks also the POS, the cards, and broadcasts events through Kafka to several microservices, such as fraud detection microservice and American back office microservice. You can reach me. This example is available on GitHub on the Worldline organization. You can use it. feel free. Under the hood, we have a bunch of technical applications. All the microservices have their own databases. We use Postgres for that. We use Kafka for broadcasting events. All the microservices are also exposed through an API gateway, the Spring Cloud gateway. And there are other technical stuff such as the discovery server, the configuration server. I won't talk about that during this presentation because it's useless for now. So how to make this platform fully observable? So yes, this diagram is really too complicated, so we will dig into it in every part. First of all, the metrics. For this use case, we choose to use Prometheus for storing logs, for storing metrics, sorry, and grabbing all the metrics for all the different microservices. It's the standard way to use it. And then we will use Grafana for running queries into this database. Then what about the logs and traces? The logs and traces are grabbed on all microservices and then broadcasted through the OpenTelemetry collector, which is responsible for storing them into Loki for the logs and Tempo for the traces. I will talk a few words about OpenTelemetry collector later on. And what about Grafana? To cut long story short, the OpenTelemetry collector is responsible for putting all the data in the regarding databases, and Grafana will be responsible for creating the dashboards and running queries on these databases. So what is the OpenTelemetry collector? OpenTelemetry collector is just an ETL for all the observability figures. The ETL stands for extract, transform, load. You have on one side all the data, the metrics, the logs, the traces. OpenTelemetry collector will do some transformation. We will filter the data, for instance, for just storing the errors, if you want. You can do sampling by just keeping 10% of the transactions. And then store all the data in the regarding databases, such as Loki, such as Tempo, and so on. So now let's code. Okay. So we have an application, the EasyPay application. It's based on Spring Boot, so I have to move forward for the startup. It's not at all. I usually use a Spring Boot. So yes, the application is now started. So now let's run some queries, some requests using HTTP. You can see, okay, with the amount of 40,000 euros with the card number and the POS ID, point of sale 1. Everything is enquery, the response is accepted, we have the good payment ID, and we can see that, yes, the authorization is okay. Now let's run the same request with another amount, and now the authorization is, I would say, is normal. You can say, okay, it's not authorized, and we will run the same request with another card number. Okay, it was a one card number, so yes, the response code is good. And now, okay, we run again another request, and now let's see in the log what happens. We have nothing. The ops guy could pinpoint what is the root cause. So now let's add some logs, such as, yes, the loan case is wrong. You can add another log about, for instance, the expiration date. It's a responsibility of the developer to put all of that in place. And some another warnings about the card number. Okay. So now let's rebuild again the application. So I move, sorry. I will move again forward. Now we started. And let's run the same request to see the difference. Okay, now we can see in the logs, okay, why something's wrong. Such as, yeah, the LUN key is wrong, the authorization payment was refused, and such like. Now, what's going on? Oh yes, with another post ID. Okay, we got the typical internal server error. And let's see the log. Okay, we had the good or null pointer exception. And just to make a break, if you are on your desktop, you can pinpoint what is the root cause. You can see, okay, we have the null pointer exception, and I got the context about the payment request. You can do that, you can know that because you are on your desktops. But it will be more tricky on production. So now let's ingest some data, some requests on your application using KSX, which could be considered as a performance tool to inject some data on your application. And we can see that now it's completely cumbersome to pinpoint what is the root cause. Okay? Now, how to do that? How to bring some context for this transaction. Just a moment, please. So we really had the MDC feature. MDC stands for Map Diagnostic Context. And we will put for every request the context in the logs. And the context is here based on the payment request data. So for adding the context, we will add the context directly in the in the logger pattern, using it. Okay, if we don't have the context, put null, for instance. It will be useful. We will see that later on. And think about clearing the context at the end of the transaction. It's mandatory. So let's run again the application. I have to move forward again. And just for information, I started the application with the MDC profile, which enables MDC feature. So okay, it's completely started now. It's initialized the repository. As you can see that the context is null here. It's normal because the API hasn't been reached yet. Is it started? Yes, okay. So yes, the application now is started. Let's run the same request using KSX. So if you are developers, this operation, all I done before, could be done directly during the development phase. You have to think about that. So now, let's run the same request. You still have the same issue. It wasn't the point to fix this issue, it was to get insights. And now, you can see that for every request, we got the context regarding the corresponding survey payment request. So, as for now, we were only on the development side, on the desktop. So what happened if we go to production? Passing the files directly on the log files or on log files could be really cumbersome. You need to have a tool such as Elasticsearch, such as Grafana, for analyzing the log. So now, okay, let's move to another video, please. So the good practice is to configure logs to be, for instance, sent to the console and sent to log files. And these log files should be written in a structured way, such as JSON. For instance, here we have all the logs stored in the folder logs and formatted as a JSON. So just a few words about how we want the log files. In the way you can do that configuring your logger. And in this way, you will be able to pass your file, to pass your data and make insightful queries. So now, I talked about OpenTelemetry collector during my introduction. OpenTelemetry collector, as I said, is an ETL. So first, we have to specify where to grab the logs in this directory. And then we will make some transformation, such as how to get the application name, how to get the instance name, how to get the trace ID. We will create then labels. We can put some other transformations, such as a timestamp, but at the end of the day, we will reach Loki, we will reach tempo for storing the data. So now, I talked about OpenTelemetry collector. For this demonstration, we will use Grafana Log, which is just the Grafana OpenTelemetry collector implementation. And it brings additional features, such as a web console. And with the graph, you will be able to see all the dependencies of what you configured earlier, such as the JSON files. And you can check that, yes, when you write to Loki, it's dependent from the process, it's dependent from the source files. Now let's see how to explore your data directory on Grafana. You can check that, yes, we can use the labels we configured earlier on OpenTelemetry collector. You can run then the queries. You can check the time slot, and you can see that because you configured your logger, you configure the logs in the structured way, such as JSON, you can easily parse your data on Grafana. You can see that, okay, we have the sequence number, you have the MDC, such like. Now, we will be able to parse your data, parse your JSON, for instance, for getting the message and the log level. Okay, we run the query again. No, okay, it's wrong. And you can run the message and level equals level. So let's run the same query again. Okay. And now we can check, okay, we still have the logs, but we can get the table. And we can also filter based on these fields, such as the level and the message. And you can for instance, do the same as on GCP with the error reporting to get, okay, what are the errors on my platform? Okay, and be sure you can do that with all the other microservices. So now you can do that on the Mercon back office also. Okay. So now let's talk about metrics. When you use Spring Boot, metrics are available through Actuator. Actuator is a really useful tool when you use Spring Boot because it will help you getting, for instance, liveness probes, readiness probes. You can run some technical stuff, such as stopping the instance, getting some insights. And if you want to know what are the metrics available on your application, you can use these endpoints, metrics. You have all the metrics names. And if you want to have the corresponding figures, you can check this endpoint, the Prometheus metrics. And you can do that directly on your desktop when you develop your application. I would say it's up to you to know that. So now, what about the segregation, the system load average, in the last minute? Now let's see how we can query it on first the Prometheus dashboard, because as I mentioned earlier, Prometheus is responsible for grabbing all the metrics from all the microservices. Or you can check the status here. You can check the latest scrap duration, such like. And let's explore all the statistics on Grafana. You can run your request on Prometheus, but it could be really tricky. So I strongly recommend query Prometheus through Grafana. So let's run the explore dashboard again. You can select, for instance, the Prometheus data source, and you can run the same request. Okay, let's run again. Okay, selecting the application, the API gateway. Okay, so now you got the system load average graph. And you can navigate, you can zoom, you can do some stuff, I would say. Now, let's run again some requests to inject data in our dashboards, in the database, and navigate then to the dashboard. So let's run some data using KSX on the smart bank. So now we'll be able to get insights from specific dashboards. For instance, what about the JVM? The JVM, you can check, for instance, how are the IOs, or how is the JVM memory, and such like. For instance, you got the JVM memory, the heap, the total. You can also check the CPU usage, and such like. And you don't have to do that as a developer, because if you already provided the metrics to your application, the ops are able to get these insights. What about for instance, the garbage collection, the class loading, and so on. You can also check how is your database pool using the same tool, such as the data source here statistic. You can check that we have 5 connection active connection, 5 idle, and maybe we have one issue. So we simulated one issue in your application. Let me move forward, maybe. Sorry. So let's go again to the logs. Run again the same request with the log level, which is different from info. When you can see, okay, we have, if you dig into the logs, okay, we have a good all out of memory with the Java heap space, well known from the ops. Now we can see how to correlate all of them, metrics and logs. You can see, okay, we have just an analysis, it's not automated. You can run again the JVM micrometer dashboard. You can see, okay, you can see that the heap is saturated right now. So now let's talk about traces, how to correlate the traces and the logs. Just a moment. Okay. So, as I say, the traces are really important when you want to correlate different calls, different API calls, in different transactions, either asynchronous or synchronous transaction. How to instrument, how to put all of that into production. One way, in my opinion, is the most straightforward way, is to put beside of your application an agent and refer it at the startup using the Java agent instruction. So you can use as an argument the Java agent. You can say, okay, my Java agent, here is the Grafana OpenTelemetry Java agent. You can specify the endpoint using some environment variables directly at the startup of your application. Okay, here are all the environment variables. And just a few words, the underlying protocols is here gRPC. Okay, you can do that on all the microservices. And in this way, your configuration, your instrumentation won't be, I would say, intrusive with your code. You don't have to declare some dependencies. And one of the most important features, in my opinion, is that you will be able to see what are the dependencies between your different API calls and your different services. You can see that, yes, the user, when in which your API, it will want the API gateway and the EasyPay services and such like, and so on. It's really important you get this insight, because when you run an application microservices platform, when you have no documentation, when it's really cumbersome to know what are the underlying transactions. Here, I don't talk when they are asynchronous. So you have here the API. We can check what are the request rate. We can do some graphs on that. Okay, the page request. We can do that with Postgres also. We can get insight from the databases and Kafka. So now let's search some traces. Just a moment. Okay, here we go. So we run the trace here, and you can see we have the trace ID with the spine ID we configured earlier. And we can check the duration. We can identify what is the most time-consuming transaction, because as a customer point of view, I would say. And now you will be able to see, okay, for one API call, from a customer perspective, what are the underlying API calls and sub-transaction? What does it doing? Okay, just a moment, please. Okay, sorry. So, for one transaction, we will have here all the API calls, all the method calls, all the SQL queries run, and their corresponding time execution. And you will be able to do that for your whole platform. It's really important. And when you have to debug into production, you can normally, usually you can't reproduce this behavior in the staging environment, because it's not the same environment, the same context. And you can, with tool, you will be able to get insight directly from the production environment. It's very important to know where does it happen, what do you have a performance issue. You will be able to do that and to check that directly in production. You can see that, okay, the post endpoint is reached with this parameter, this HTTP request parameter, and so on. You can do that with synchronous API calls, but you can also do that with asynchronous call. And you will be able to correlate different methods, different calls, when all the transactions go through, for instance, Kafka, ActiveMQ, and so on. For instance, here, we submitted data for a topic, and we get it then from a 9-over microservices, and Tempo will be able, and Grafana will be able to correlate all of them. Okay. Now let's dive again. So you will see the request. You can see all the requests for all the microservices. Let's move forward now. I don't have time enough. So now, how to correlate the logs and the traces. Let's go back to the logging dashboards with querying on the Loki. Don't worry about these issues. They are normal, I would say, due to Zscaler. It was true, by the way. And with the MDC, you can check that we have here the span ID and the trace ID. And using this ID, you will be able to correlate and navigate from the trace to a log, to corresponding log, and the other way around. Okay? And by the way, you will be able to know, okay, what happens, and where does it happen, what is the corresponding functional transaction. And I will stop here with the demo. Okay, you can check the trace again here. You can query again and see what is the corresponding trace. So now let's go back to the slide. So to sum up, few key takeaways. Observability is now a feature. It's not just a bunch of tools you ask the production to put it in place a couple of weeks ago before putting all of that in production. No. It's really important to anticipate this implementation. Now it's simple, it's really straightforward to set it up. The Grafana Stack is really easy to put all of that in place. You can do that also on GCP using traces, log monitoring. You can do also cloud monitoring, which is based on Prometheus. But think that you can do that also on legacy applications. You can do that on the good old Wi-Fi Java application server. It will work. And then, last but not least, think about performance. Because when you put live the traces, perhaps you will get an overhead if you have a high pressure application with more, for instance, 500 transactions per second. You have to identify, you have to pinpoint what is the overhead of these tools and these metrics. So our line, we think we have a shared service. And I don't think I'm the good guy to talk about it, but normally it would be David. But think that we have a shared service which provides a Grafana Loki Mimir to help you bringing all of this feature, the observability live for our application. So now, thank you very much. If you have any